Hello, everyone out there on the internet. Welcome. Today we are going to take a brief kind of look at a problem that is affecting all of us and talk about what TransGenada is looking at to do to fix it. So we are TransGenada, and we are looking at a problem that faces all of us here on this wonderful planet we call home. With me today we have TransGenada's head scientist and CEO, Dr. Jeremy Ellis from Arizona. Hey, Jeremy, how you doing today?
Doing okay, and yeah, it's a great picture of me there presenting at our seed presentation meeting. But yes, doing good.
I like the action shot. So anyway, let's dive right in. So we're looking at a problem that affects all of us, and I just kind of wanted to give people some scope. Here are some pictures from around the world. These are all probably places people are familiar with. Here's Los Angeles, my neck of the woods. 15 million people call this place home. New York City, 19.7. Tokyo, 32.5 million people. Seoul, South Korea, 20.6 million. I'm not sure how to say Jakarta. I think it's just Jakarta, Indonesia, 18.9. Oh, Jakarta. All right, so as you can see from this graph, and we didn't look at everything. There are other cities on here, but there are just tons of people. And Jeremy, I was wondering if you could kind of outline what's going on in this graph for us.
Sure. And basically, since, I guess the dawn of man, there's been a gradual and then more recent explosive growth in human population. And this graph basically outlines that. And each year where the human population surpasses a billion mark is marked at what year that occurred. And so we start down here at 1804. We have approximately 1 billion people on the planet. It took us quite a while until 1922 to reach 2 billion and so on. The most recent estimates you can see here marked by the red circle were the estimates for 2010. You can see we're pretty close to the best estimates we have at the time. And then projecting forward, you can see in 2018 we are shooting for 8 billion all the way up to for 13 billion in 2039. That's going to be in our lifetime. So that is a lot of people. I mean, you think about it today. This is 2012. We're coasting somewhere around 7 billion people, and we're going to have 13. That's almost twice as many people.
Within 40 years, 30 years? Geez.
Yeah, that's a really short period of time. That's going to be a major problem. And, to be able to support that growth, that's a major issue. So,
in science, do they have a name for this kind of a slope?
Well, yeah, this is definitely an exponential curve here, where it's compounding upon itself. And we can talk a little bit about why it actually has this feature.
Okay. I
think we have a good graph actually to show that.
This one, is that what you're talking about?
Yeah. So basically, this is showing sort of the long-term historical, population profile. And you can see for an extremely long period of time, going back to 8,000 BCE, there's a very, very low population growth. And this is, again, the previous graph was looking under a very, very short period of time. So we're only looking at the very far right-hand part of that curve on that other graph. But when you look at the whole, the whole graph and the trend in general, it is exponential at this very end here. And by and large, you can see there's this very slow growth of increase. And we have a small dip here that's actually marked by the plague. And then shortly thereafter, we have this massive increase. And simply, the periods of growth have been supported by, as highlighted here, various technological innovations that actually support the advancement of society at large and support the people. And this includes agricultural revolutions, the invention of antibiotics and medicines, energy technologies and computing technology, etc. So really, it's just to show this sort of very little happened for a very long period of time, and now we have this massive explosion that's supported by these technologies. And that's kind of where we think that TransGenada sort of represents an outgrowth or to support that massive expansion.
So is this, just to throw a question from left center, I know science doesn't usually deal with questions like this, but is this a good or a bad thing?
The massive increase in population?
Well, what we're seeing here in this graph.
Yeah, it's basically, obviously people like to have and families and reproduce and things like that from a personal standpoint, obviously that's a good thing. It's from a scientific perspective, it's actually a bad thing because this can kind of put us in a precarious position where we are sensitive to external factors, whether or not there's enough food to support. There could be famine, disease. A lot of these sort of considerations happen when you sort of stress out a particular environment, and that environment being Earth. And we're really stressing and tapping all of the resources that are going into supporting us. So without, intelligent application of technology and thinking ahead, you could be putting yourself in a precarious position by having a huge number of people. Does that answer your question?
Yeah, it does. So you are first-hand information here, as you just added another chalk mark under the number of people on this planet.
I did.
Congratulations, by the way.
Thank you. Yes, I did just have yet an offspring, so one more. I think I'll be done for now. So.
All right. Well, I won't go into details since this is a public setting, but so let's move on to the next point here. And so, there's a problem. We're growing very quickly, and the question is, well, what do we do? In the past, in that graph, you saw that basically how we were able to support larger populations was because of innovation, technology. We were able to control things like disease or improve our quality of life, and basically that allowed us to have more people. And the question in my mind is really, well, with this many people expected in the next 20, 30 years, are we going to be able to keep up? Is technology going, how many iPads is it going to take to support all these people in the world? And I've already kind of filled in the answer here. One of the things that we are looking at that is going to help support all these people is aquaculture.
Yeah, this is simply food. That's it. This is food.
Yeah. So can you explain what aquaculture is, I guess, in a nutshell for people that aren't familiar?
Sure. Simply aquaculture is farming that's not on the land, which is agriculture. This is sea farming, typically of it's usually of small animals, or it can also be sometimes algae and other aquatic plant products. But typically anything that's grown in water, but it's farmed in that sense. So.
Gotcha. And in fact, you kind of answered one of the slides here. So we've got fish, shrimp, oysters, algaculture, which is, I guess...
Aqauculture, yeah.
Aqauculture, and I know there are a couple others, but those are the major ones. So that's what we're talking about with aquaculture, but it's different than wild caught. Going out on a boat and catching fish or shrimp is different than what we're talking about. We're actually talking about growing them either inland or near a water source in a contained kind of environment, right?
Yeah, absolutely, and I think that's really key to demarcate that we're not actually harvesting the natural environment for these. And you can control the environment to maintain a quality of food then. They're not exposed to various sort of environmental factors that are out of your control, and you can increase the productivity. And if it's done correctly, you can actually decrease the impact in the environment overall. So, yeah.
Excellent. Well, before we get into that, I just wanted to give the folks at home kind of some quick facts about aquaculture. There's a lot of information out there, but just, it's a relatively new topic, I think, for most people. So just a couple tidbits. Half the fish that is consumed is from farmed sources, and that's growing, by the way, growing very quickly. In fact, aquaculture is the fastest growing animal food producing sector out there. And currently it is dominated by the Asian Pacific region, places like China, Thailand, Indonesia, Pacific Islands. All of these are major players, and some specialized in different various products or whatnot. And the other thing I wanted to say, it is a young industry. Really, it's something it's been around for, I think, over 6,000 or 4,000 years, for a long time, technically. But we really haven't...
But as an industry.
As an industry, it's relatively young. Exactly.
Yeah.
And, there are some problems. And I wanted to... This is really why I wanted to bring Dr. Ellis on here, is to talk about some of the problems behind... and we're dealing with shrimp, so a lot of these are specific to shrimp aquaculture, but they're probably universal, but we're specifically looking at shrimp. So I wonder if you could look at kind of some of the problems facing the shrimp aquaculture industry.
Sure. It's actually interesting because there's been a lot of reporting about the good and the bad in the shrimp farming industry, and it's not perfect, and I think that that's really where technology can come in to answer a lot of those problems, because it is a relatively new industry, as Andrew had mentioned. So, one of them here basically is talking about the environmental impact. I mean, if you compare and contrast the difference between wild caught, well, what you're simply doing is you're removing animals out of their natural environment, and that can weaken or disturb natural food chains. And in fact, if you look at population growth of certain fish populations, or even just the sizes of fish in the ocean, they are extremely suppressed at this point because we're pulling out so many animals out of the ocean. So we're really stressing out sort of the normal fishery and ecosystems and their overall production. It's not really just an endless pool to keep pulling from. You contrast that to farming, where a lot of the prime let's say shrimp farming land is mangroves or other sensitive habitats. So they'll go in and actually remove those habitats, which is, somewhat of a downfall for that local environment.
So kind of like what we're, like the whole depleting the rainforest in South America, we're doing the same thing to mangroves in the Asian Pacific areas?
Yeah, how they're slash and burning rainforests for cattle farming, they're doing the similar thing for the mangroves. And I think this is really where technology can help clarify some of this, because clearly we don't want to be pulling out natural populations and causing ecosystems to collapse in the wild, and we also don't want to be destroying sensitive habitats, being mangroves that are important for watershed and local environments and ecotourism and stability of the ecosystem. But I think there's a solution that answers all of those. The next thing here, talking about human health, clearly since a lot of the raising of these animals and shrimp aquaculture specifically is done in sort of more of the developing countries or developing world in the Asia Pacific, they don't adhere to the best of farming practices. And so again, you've heard a lot of hullabaloo about finding that some of these shrimp are containing high levels of antibiotics or other types of chemicals that are not, we do not want in our food supply. Again, I think that an appropriate application of technology and maturation of the industry will really get a handle on that and sort of wipe that bad name clean.
Gotcha. Real quickly, for the people at home that aren't familiar with why it's bad to have antibiotics in their food, could you maybe explain, because this is relatively new to me?
Yeah, it's actually appreciating the overuse of antibiotics in agriculture and aquaculture specifically is a problem, because having low dose or constant exposure to an antibiotic can actually breed antibiotic-resistant bacteria. And it's been seen time and time again. Actually, various studies have shown in different types of meat products that are in market, you can find that there is antibiotic-resistant bacteria in those that are grown in farms that use antibiotics. Oftentimes, these antibiotics are used indiscriminately because they do improve yields, because they will reduce the random infections to the animals, but that's a short-term solution. In the long run, we're just breeding tougher and tougher bacteria to deal with. So it's a problem, because food is one way in which you get exposed to bacteria, and you don't want to be picking those up.
Gotcha. So basically, they're given animals like cows or shrimp or fish antibiotics to keep them healthy, so that they're the farms are more productive and they can increase their profit margins. But then when people ingest those animals, like if I eat, those animals or enough of those, my resistance to that antibiotic goes down. So if I get sick, what happens to me?
Yeah, exactly. I mean, you're going to have antibiotic-resistant bacteria on board, and the treatments will be less effective.
Gotcha. Okay, so that's a big problem, not just with aquaculture. That's probably in cattle and everything.
Oh yeah, that was actually where it was first identified. Was in the cattle, poultry, and bacon and pork industry. So.
Okay, all right. Well, I'm not going to give up my bacon, but let's move on. Let's get back to shrimp. So. Boom and bust cycles.
Oh yeah, absolutely. I mean, here the problem with the industry is that they will go through cycles of massive production, where everything works very well for many, many different farms that are producing, let's say, specifically shrimp. That drives down the cost. Well, that's a big problem, because then the farms are not sustainable. So even though they have a massive production, and everyone overproduced, they now are scraping to get by. The bust cycles, and shortly follow up, typically move along with outbreaks of disease or other illness, and this causes it so there is no production of shrimp, and the overall productivity goes down. That drives up the international market for shrimp and other related commodities. And that will then entice more people to get involved, where there's a higher price. So, hey, I'm going to go start my own shrimp farm and jump into this industry. And then when everything renormalizes and the diseases sort of go away, now there's too many producers, and then it will drive down the cost yet again. So it's a vicious cycle that this industry really is suffering from. And again, maturation of the industry and again technology will help sort of level this out in the long run.
Gotcha. So it's like a gold rush for shrimp, but sometimes there's no gold and sometimes there's too much gold. And I definitely experienced it here. Place near me, I'll walk into, and every once in a while they'll charge extra for shrimp. They'll have a handmade sign that says $2 extra for shrimp. I always take note of it, obviously, but it's kind of the way it is. It's a very volatile market. I don't know if you call it that, but it definitely fluctuates quite a bit.
Yep.
So you mentioned disease, and this is pretty key within this industry. I wonder if you can talk a little bit about how that's problematic for this industry.
Well, sure. I mean, diseases, whenever you have many animals that are living in a crowded environment that are of one kind, there is a lot of disease problems. And this is really magnified in aquaculture because literally they're all swimming in a shared medium. Which is different a little bit from organisms that are separated by air. There's a lot less things that can sort of find their way through the air other than sneezing and coughing and cold viruses. Those typically need to have some type of method to disperse, whether it be on droplets or something like that. But when you're actually swimming around, diseases can really move between animals very easily. So you'll get an outbreak of a particular virus or a bacteria in these crowded pond areas where they're trying to grow one type of organism. Let's say it's a particular kind of shrimp, and it just goes crazy and will wipe out their volume of their farms, and it will really knock down the production. They may lose entire crops 100% because of these breakout of illnesses. So definitely it will knock down the production volume of the farms, sometimes to complete zero. And since they're trying to maximize the production, and it'll actually cause it so it's a very sensitive environment to disease. And as we marked here, the screening is actually really, really inadequate at this time. The reason being is...
What does that mean, screening?
Yeah, so here they're looking at animals that they're going to be adding into their ponds. So they start with brood stock or these seed stock that they buy from some other third party, or actually sometimes they'll go out in the wild and capture them to stock their ponds with and grow them up to actually the size that they want to be for market. And typically they're going to look to see if these have any sign of disease. Well, the ways in which they're screened typically are by morphology alone or other characteristics, and it's really doesn't catch everything. A lot of these animals can carry viruses or other disease and be completely asymptomatic, and it doesn't show up. So it can be dormant illnesses. Molecular detection, methods have come a long way to help that out, but it still has not fully improved everything at this point. And also, did you have a question?
Well, no, I was just going to say, so it's not like with humans you can just put a thermometer in our mouths, and if our temperature's a little high, something's wrong. It doesn't work that way, huh?
No, I mean, you can have a shrimp that looks completely normal and healthy for generations, actually, but they're harboring a virus, and eventually something happens to stress out the animals, and boom, you lose your entire crop as the virus rages forth. So, yeah.
Well, okay. And this last point, inadequate prevention technologies. What technologies are out there to prevent, to help these farmers not lose their crop and to help, the people at home get affordable shrimp?
Right. The prevention technologies at this point are literally, again, they're doping the environments with lots of antibiotics or other chemicals that may or may not actually reduce the overall illnesses and diseases that are seen in their stocked pond and culture situations. That's one way. The other prevent, but that again, that's not necessarily sort of a shot in the dark, and that's actually being now regulated against. The other methods they're trying to use mechanical means to remove organisms from ponds and stocked conditions. So this is actually trying to filter out the problem-causing animals. Oftentimes they'll try to set up an environment where they'll have a clean farm where there's no virus, so they'll create a brand new farm. And there's no viruses there or no bacteria that are causing problems. They will stock them with animals that have been screened as to the best of their ability to be negative or not harboring any of these diseases. And again, that's just sort of hoping and crossing your fingers that a virus or some type of a disease doesn't find its way into your pond and basically wipe it out. Once it does, oftentimes those ponds will be left and then we'll move to a new area because it's easier just to build a new farm rather than trying to deal with the problem at hand. So
risk-free contamination, huh?
Exactly. So
it's kind of like what they did in the 1800s where they just burned down the house.
Exactly.
All right. Well, let's. This goes to the next point. So, what's being done? And you mentioned breeding. They call it SPF sometimes, where they're basically trying to pick the Hercules shrimps, the guys that are automatically a little bit more immune to it than the other guys. It's not a perfect science, but you mentioned that.
Actually, SPF is a little bit different than that. I think I want to say is SPF are shrimp that are certified to be pathogen-free. They're not necessarily resistant. But you're right. They typically do try to take the SPF shrimp and then breed into them the ability to resist disease.
Gotcha. So these are certified that they didn't come with any disease.
Exactly.
But they do have lines where they breed them and make them. The idea is if you get generation after generation of shrimp that didn't have the disease, you're probably selecting for genes that make it stronger.
Yeah, potentially. Some farms actually will take animals that survive outbreaks and then breed them together. And then those will have increased survivability to disease, but then they have to make sure that there's no viruses in there. And so, yeah, you're hedging your bets a little bit. But in terms, there's two different ways to do it. So.
Gotcha. Okay. Well, let's get some of these other points here. Recirculating farms, you kind of mentioned that. Have you talked about the recirculating aspect? I think that's just what you're talking about with being isolated, that sort of thing, so it stays away from disease, right?
Yeah, really, that's the idea. Is that in recirculating farms is you have it in a building where you're not exposed to the environment. You don't have birds bringing in viruses from other areas, and there's no exchange with water with external sources, so there's no risk of contaminating the farm. And that's one of the newer things here, but it is energy expensive, and the plus side is you can typically have these types of recirculating systems in areas that aren't naturally primed for raising shrimp, so they can be in a cooler climate or a drier climate given that the right energy sources are available. But yeah, that's really the idea behind recirculating farms. You'll be able to grow them in your backyard and it'll become more of a local food source.
Gotcha. And now this crop rotation I wanted to actually talk about because I found this so titillating as a grandson of a farmer. I understood that they have different tricks or techniques that they'll do to try to get the best out of their farm, where they'll have different fields and they'll depending on the season and market value and everything like that, they'll tend to put different seeds in different areas. So maybe wheat one year, or corn the next. And what I found was so amazing is in an article that I read on farmers in Vietnam that were actually doing a similar thing with species of shrimp. Black tiger shrimp is the bigger shrimp, and the Pacific white shrimp is the smaller shrimp that you find in like shrimp cocktails. And they would, depending on the time of year, they would grow different, either the tiger shrimp or the Pacific white shrimp, because of I guess there were seasonal differences or probabilities with disease. So they're basically hedging their bets, just like my grandma would on her farm. And I don't know if you saw this or not, but on Twitter it was on the blog. We got a message from a shrimp farmer in Bangladesh that he does the same thing. So pretty interesting. I don't know if you want to throw anything there, if you want to move on to the next point.
No, I think the only other thing is I think that the crop rotation in general in aquaculture isn't nearly just limited to rotating shrimp species. I have read about how they will rotate between fish one year, shrimp the next. And actually there's some benefits to having sort of a mixed culture system, which is some farms are adopting. But we'll see how it works out in the end. Again, this industry really is in the early phases of industrialization. So.
Gotcha. Now, I've been reading a lot about them people trying to develop, like, innovate the food source within
Mhm.
aquaculture. Can you speak to that?
Yeah, a little bit. I mean, really, that's one of the major overhead costs besides water and personnel costs is the feed. You have to basically feed these animals and feed them consistently to grow them to size. These animals are going to use the energy and the caloric content of the feed to conduct their daily activities, swimming around, doing shrimp things, seeking for more food, stuff like that, molting and growing. So the idea here is if they optimize the feed sources and they're very energetically favorable and cheaper, then it makes this industry a lot more favorable to bring these animals up into the market. One more thing that I need to talk about feed is actually turning out to be an interesting way to deliver certain types of characteristics or not necessarily medications as we would consider them, but ways to change the performance of the animals in that aquaculture environment.
So we're talking like protein shakes for shrimp to make them more muscular?
Well, I mean, yeah, there is a little bit of optimization of the different nutritional factors in the feed, but I'm talking about more about by reducing, let's say, even diseases by changing what they eat. So, for example, if you have shrimp that eat a sort of a probiotic, that's a term used in some medical industries, doped water system, there actually is there are more beneficial bacteria present, and that actually can spur the growth and the survival of the animals, even in the presence of disease.
Huh. Interesting. All right. Well, let's look to the future and let's talk about what TransGenada is doing. I know we can't necessarily go into specifics, but can we give people out there a little bit more than we have in the past?
Well, sure. I mean, TransGenada basically our main charge is to bring modern molecular biology and biotechnology to bear in all the aquaculture industry, which has almost been, except for a few specific exceptions, has been almost completely ignored at this point. This is really doing what has been done for other industries, being the pharmaceutical, biomedical, and the agricultural industries, but applying it to the aquaculture industry specifically.
Gotcha. Okay. Well, I really appreciate you coming on my little show and explaining this stuff. It was very helpful, and I hope everyone at home enjoyed it. Thanks.
Thanks.